the context of database backups. So we absolutely rely on VSS. And a lot of customers, when we first start having conversations with them about them, I'd say probably approaching 50%, maybe 40% of customers have had some prior experience with VSS that left a bad taste in their mouth. So I wanted to just describe a little bit about the VSS components and how they work with each other, and then how we use them. And then as well as talk about some of the safeguards that are in place that Microsoft has put into VSS, and how it gives us the flexibility to do what we do without the high risk of impacting the production environment. VSS is made up of 4 different components. First, there's the VSS service. It's what I call the VSS engine. It's the core component that manages it all. It's the one ring, if you will. Then you have the writer. The writer is the integration between the engine and the data source. So the writer is provided by typically the vendor that provides the data source. So in this case, we're dealing with Microsoft SQL Server. The SQL Server team created a VSS writer that fits in the VSS framework that the VSS service can talk to, so that when it goes to take a snapshot, it can talk to the writer and say, hey, get these databases into a consistent quiesced state, please, and tell me when they're ready. And that back and forth takes place automatically between the two. The next component is called the provider, and the provider is on the other side from the writer, where it's handling the actual snapshot management. So the VSS framework, the VSS service, it's just the engine. A lot of people think that a VSS snap means that Microsoft is taking the snapshot. That's actually not true. It's the provider that's taking the snapshot. And a lot of implementations out there from a lot of vendors, including just flat out VMware with VMware snaps, they provide their own VSS provider. Storage providers provide their own VSS provider, so that you can take a VSS snap that's not actually a Microsoft snap in the operating system. It's a storage array snap on the underlying storage array. Right? The provider is what manages that snapshot. And then, of course, the final is the requester. The requester is what's initiating the whole process and asking the VSS engine to create a snap or delete a snap, etc. The way that we use VSS, Actifio is the requester and the requester only. And this is a really important differentiation because so many third parties provide the provider. They created a provider, and a third-party provider most often introduces high latency. People try to integrate things like change block tracking, for example, into the provider, and we have not, right? But by putting it into the provider, what you've done is you've introduced latency into the snapshot. And the snapshot process is the requester says, please take a snap for these databases. The VSS service says, okay, I'm going to ask the writer to quiesce these databases. Tell me when they're done. And it does. And you see in your SQL Server logs, IO frozen for database X, Y, Z, etc. Then VSS engine goes to the provider and says, I'm ready, go ahead and take a snap. There's a Microsoft provider. The Microsoft provider is very, very fast. It also has a lot of safeguards in it that I'll talk about on the next slide, but it's very fast and it's local inside the machine. And as soon as the provider tells the VSS service, okay, the snap is done, the service goes back to the writer and says, okay, you can unquiesce and resume your regular IO activities. And then once that's finished, the VSS service tells the requester, okay, your snapshot is now ready. So that's the sequence of events. Now, if you look at a system that is doing it with all native Microsoft components, Microsoft Writer, Microsoft Provider, and of course the engine is always Microsoft, what you will see specifically for SQL Server is that your IO frozen messages and your IO resumed messages, they all happen within 1 second of each other. They're very quick. They're typically well under a second. Even on systems, and I've seen this, even on systems where you have hundreds or even 1,000 databases I've seen get snapped in 1 second using the complete Microsoft stack. Now, if you instead have a third-party provider, then what happens is the volume shadow service, the VSS service, goes to the writer, says, go ahead and freeze the IO, do your quiesce. SQL Server does it. Then it goes to the provider and it says, take your snapshot. And then it has to sit and wait. And if that provider has to reach out to a storage array or talk to VMware, if the provider is coming from VM tools, there's coordination across different applications running sometimes on different physical hardware across networks. And believe it or not, the more fully functional and feature rich that provider is, the longer it takes before it comes back and says, my snapshot is ready. And during that time, your IO is frozen. And so a lot of customers, the bad taste in their mouth from VSS is, I took a snap and my user's connections got dropped because they timed out. They timed out because IO was frozen for too long by that waiting for the provider. So using the all Microsoft stack, that eliminates that latency. That's one of the things that we wanted to make sure that we did. Now, in addition to the latency at the time of the snapshot, there's a couple of safeguards that are built into the VSS provider from Microsoft. First is space consumption. You know, it's pretty obvious when you have a snapshot and you've snapshotted a disk that is live and having changes, you're consuming some extra storage, right? Because you have to store the blocks that differentiate from each other. So what we've seen, what Microsoft did, is they said, we're going to prioritize the production volumes stability over the snapshot. And so if you start running out of space to handle storing all those changes, VSS provider from Microsoft will automatically delete snapshots. I've seen this happen sometimes on a customer system where they don't have a lot of free space on their disks and they have a big database or a bunch of big databases. The first full backup sometimes while it's running will fail. And when we look at the failure reason, it says the VSS snapshot was deleted. We look at the Windows VSS logs and it says we're running low on disk space, deleting the snapshot. So it always prioritizes the stability of production over the snapshot. And that's exactly what you would want. You can handle a failed backup job. And I'm going to tell you in just a second on how you can address that kind of a problem. But handling an outage because you ran out of space on a production volume, well, that's much harder, of course. And while most people, I think, probably know that VSS has that space consumption safeguard, they might not know that it also has an IO safeguard. And I saw this too just a couple of weeks ago at a customer site, again, trying to take the first full backup on a couple of volumes. They had about 50 volumes in scope, and 2 of them had much higher IO. And it wasn't even all write IOs. It was a lot of read IOs. But what happened was VSS provider, it allocates space to the snapshot. And when that space fills up, then it allocates more. And it does it in chunks. And at the point of time when it does the allocation, it actually has to pause IO very temporarily, but it has an IO impact on that production volume. So the way the provider works is it's so tightly integrated with the core disk drivers that it knows to prioritize production IOs first. And so it sits and it waits for a gap in the IO long enough for it to do its work that won't affect the production IO. If it can't get one, it will say, hey, I can't allocate more space for the snap, therefore I have nowhere to store these changes, delete the snap. So even though we had plenty of disk available on those drives, we still had the snaps delete in the middle of our job because it couldn't handle the IO required to allocate space to the snapshot without impacting the production IO. And Microsoft VSS provider always prioritizes production over the snap. So how do you get around these problems? Right? Easy. They being Microsoft, they also give you the ability to pick what disk should be used to hold the snapshot deltas. And it doesn't have to be the same one as the source disk. So you can either allocate a new disk or pick a disk that has space. You do want it to be similar performance characteristics to the production disk because it's going to be getting copies of data from production. But you can pick a different disk. And by doing that, number one, space management obviously becomes separated. So you can have a disk with lots of free space on it, use that for your snaps, and never worry about the space on your source volumes. And number two, that I/O intensive or impactful operation of allocating more snap space, that goes away from the production disk. It's on a different disk. Now you don't have disk contention for it. And so simply going into Windows Explorer and picking to use a different disk alleviates that problem when it comes up.
Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.